Hi, I'm Jay Gould and I'm here to demonstrate the new Xilinx Connectivity Platform Development Kits. For high-speed design applications, Xilinx provides a solution built on the Virtex-6 FPGA platform using high-performance GTX transceivers. And for cost-sensitive applications, we have the very easy-to-use Spartan-6 solution that integrates common industrial protocols like PCI Express and Gigabit Ethernet. These development kits will enable you to get started quickly, evaluate the silicon technology, and accelerate your development for high-speed serial designs. The targeted reference design that I'll demonstrate bridges between popular industry protocols Gigabit Ethernet and X1 PCI Express running at 2.5 gigabits per second. The design also showcases data movement through off-chip DDR3 memory, interfacing through the built-in memory controller block of the Spartan-6 LXT FPGA. This interactive reference design is a complete design framework. We provide the hardware design, including the source for the top-level RTL integration, software device drivers, and a user interface to demonstrate the full silicon capabilities. Now let's get started. The demonstration uses PCI Express and Gigabit Ethernet, so we're going to use the following components: the Xilinx Spartan-6 connectivity kit, a desktop PC system with a X1 PCI Express slot on the motherboard, CD-ROM drive and USB port, monitor, keyboard, and mouse, and in this case, Fedora Linux operating system. You can also implement serial connectivity designs on the platform by booting up the board standalone, and we provide an iBERT design that will enable you to understand the GTP transceiver capabilities of the Spartan-6. Now, let's take a look at the Spartan-6 connectivity kit. When you open up the kit, you'll find on the top a welcome letter which lists the kit contents. The kit ships with a step-by-step hardware instructions. You will also find a complete Getting Started guide with details on how to evaluate and modify the reference designs delivered with the kit. The Spartan-6 SP605 board. We support the following serial protocols: PCI Express through the PCI Edge connector, Gigabit Ethernet through the RJ45 connector and the SFP connector, proprietary serial protocols through the onboard SMA connectors. On a memory stick, we deliver the targeted reference design framework, including the top-level RTL source files, hardware design files, simulation environment, implementation scripts, software drivers, and an interactive user interface. The USB stick also includes electronic copies of all the documentation. Each kit comes with a full seat of ISC design suite that includes the tri-mode Ethernet MAC core and other relevant IP. You will also find that the kit ships with all of the necessary cables, modules, and power supplies. Now, if you're a PCI user, you'll be excited that we've made adoption of PCI Express simple and straightforward. When you purchase the Spartan-6 connectivity kit, you're entitled to a full production version of the Northwest Logic PCI Express packet DMA IP core. This is not an evaluation or timeout core. It's actually a full production version of a DMA design so that you can use it to create your own solution. So here I have all the hardware pre-connected and working to demonstrate the capabilities of the Spartan-6. The SP605 board has been plugged into the PCIe slot of a common PC chassis. The design already comes preloaded on the FPGA, so when I boot the PC with Fedora Linux, I have the card up and running. I have followed the instructions from the hardware setup guide so that I can use the SP605 board with the PCIe Gigabit Ethernet targeted reference design and enable a networked interface controller function. You can see that we have a live system now showing internet traffic running the Xilinx demo off of the YouTube website. We've included an interactive reference design interface that will help you evaluate system parameters and measure the throughput performance. I've launched a performance monitor application and would like to know the bandwidth utilization of the interfaces that I'm working with. Looking at the PCI Express statistics on the graph, we can see that we are utilizing greater than 90% of the available bandwidth. PCIe runs at 2.5 gigabits per second, and with 8B, 10B encoding, the maximum theoretical data payload bandwidth achievable is 2 gigabits per second. If I account for the usual 10% overhead due to operating system latency, maintenance and software application traffic, The realistic data bandwidth will be approximately 1.8 gigabit per second per direction. And here I am demonstrating 1.7 gigabit per second in real time on this commonly available desktop PC system. We can attain that bandwidth because we have a highly efficient and optimized DMA engine managing the PCIe IP block in the Spartan-6 device. Let's see the source of the data. We have random data that is initialized by the driver, delivered through the PCIe channel, and is finally written to and/or read from the local DDR3 memory. For accessing memory data, the Spartan-6 connectivity kit provides the complete solution, that is, a virtual FIFO memory controller design implemented around the built-in memory controller block and delivered as source code. This will enable you to modify the design to meet your own application requirements. As you can see, I can adjust some of the packet size settings on the DMA channel connected to the DDR3 interface. I also have a status window that instantaneously updates the raw bandwidth and provides status on the DDR3, Gigabit Ethernet, and the PCI Express interfaces. So let's summarize what we've just accomplished. We've seen a quick demonstration of the Xilinx Spartan-6 connectivity kit, exercising the built-in blocks, including the GTP transceivers, the PCI block operating at 2.5 gigabits per second, a DMA IP core from Northwest Logic, a DDR3 memory controller, and a Gigabit Ethernet interface. With a targeted reference design, we enable you to jumpstart your application development. The platform includes top-level RTL source files, hardware design files, a simulation environment, implementation scripts, software drivers, and an interactive reference design user interface. The Xilinx Spartan-6 connectivity kit provides you everything you need to get started implementing high-performance serial I/O applications on Xilinx FPGAs today. Thanks for watching our quick demo. You can order the Spartan-6 or the Vertex 6 connectivity kits online at xilinx.com/kits.